On November 23rd, ThreeI Atlast once again appears to be veering toward Mars, and something strange is happening with Atlast all over again. ThreeI Atlast keeps breaking every natural comet model we have. James Webb once recorded Atlast skimming frighteningly close to Mars before its trajectory suddenly shifted cleanly away with no explosion, no massive dust cloud, nothing that could explain the maneuver, as if an invisible hand had nudged Atlast aside at the last moment. Layered on top of that are the absurd scale of Atlast, its unnaturally well-aligned orbit with the planetary plane, its anomalous nickel-iron chemistry, a jet holding steady at 90 days to the Sun, Hydroxide radio absorption, showing Atlast is breathing non-gravitational acceleration with no matching loss cloud and a network of 7 jets that could easily be read as a propulsion system. More than 15 spacecraft together have drawn a portrait of ThreeI Atlast wrapped in a symmetric dust cocoon, a gigantic UV hydrogen halo, a crescent dust shell, a skewed tail, a warm resilient core, and an orbit that keeps getting gently pushed without any obvious physical price being paid. In the end, Atlast sits between two extreme verdicts, either a natural artifact not yet decoded that will force humanity to rewrite parts of physics, or a finely controlled structure slipping through the solar system without revealing its identity. And now, as ThreeI Atlast begins to bend its course back toward Mars, we continue the journey into its mystery and confront the most unsettling possibilities of what might happen if this visitor is no longer just an unusual comet. ThreeI Atlast first raised alarms not in a press room but in a trajectory file marked Mars Risk. James Webb had been tasked to watch Atlast slip in from deep space, and the earliest arcs from Webb locked ThreeI Atlast onto a path that sliced disturbingly close to the red planet. In the first solutions, the inbound line of ThreeI Atlast threaded straight through a narrow corridor, where the Martian atmosphere swelled just enough to matter. Impact probabilities were still low, but the projected footprint of Atlast stretched across Mars like a thin grey bruise on the plots. Update after update, the tracking loops tightened around ThreeI Atlast. Each new Webb pass shaved the error ellipse smaller, and instead of drifting away from danger, Atlast seemed to hold the risky corridor as if following an invisible rail. Engineers are used to orbits wandering as data improve, but ThreeI Atlast clung to the same near-grazing geometry for longer than chance felt comfortable. The closer Atlast came, the more the projections looked like a deliberate flyby design, a brush along the edge of a planetary well that ThreeI Atlast had never visited before. Then, over just a handful of solution cycles, the line began to tilt. Without any obvious flare from Atlast, without a surge in brightness, or a sudden dust fan, the nominal path of ThreeI Atlast eased upward, lifting the corridor clear of the Martian limb. Photometry teams combed the James Webb data for signs that ThreeI Atlast had paid for the change with a violent outburst. The light curve of Atlast showed the usual flutter of an active body, but no huge spike, no blooming plume that could justify a precise, well-timed shove. To the flight dynamics groups, the residuals around ThreeI Atlast shrank obediently as the new path settled in. On paper, Atlast simply never hit Mars. In practice, ThreeI Atlast had walked right up to the edge of the well and then stepped aside with surgical neatness. A natural explanation says that ThreeI Atlast always missed, and only our early ignorance made the pass look close. A darker reading notes how sharply the corridor bent away, how no detectable blast accompanied the escape, and wonders whether Atlast carries a guidance logic of its own choosing at the last moment to leave a planet untouched. Atlas glowed as a soft cocoon of light in the dark, a quiet visitor framed by rows of careful numbers. Brightness curves traced how Atlast waxed and faded. Orbital plots showed how the path slipped neatly through the planetary plane. Each graph about Atlast came with calm explanations of dust ices solar heating the language of a strange but natural comet. Yet through every caption and every voiceover, one anchor never appeared beside Atlast on the screen. No radius, no diameter, no simple statement of how large Atlast truly was, only beautiful imagery and reassurance. Without that scale, every estimate of mass, every calculation of outgassing, every non-gravitational nudge for Atlast hung in the air. The scientist felt the missing number like a silent note in a familiar chord, a gap humming around Atlast and the data. If the true size of Atlast stayed unnamed, then all the elegant models resting on it were only guesses in disguise. In that managed silence, the most important clue about Atlast was not what had been shown, but what had been carefully left out. In the scientist's mind, the entire solar system shrank into a darkened room, every planet reduced to a cold glass marble resting on a table. Amid that dust and rubble, ThreeI Atlast was not a stray grain of sand, but a towering block of ice and rock like an iceberg drifting in close without a sound, and Atlast quietly stole the scene. The first interstellar visitor had been only a fine scratch across the sky. The second was larger, but still just a wandering stone, nothing like Atlast. Then Atlast arrived, and the inferred diameter vaulted straight into the kilometre scale, snapping the smooth statistical curves that theories had drawn. If the universe threw debris between stars at random, we should have collided with countless small fragments long before a giant like Atlast ever appeared. Instead, with only 3 known visitors, Atlast has already claimed the most extreme position out where every plot once labelled the region almost impossible. The scientist pictured a hat filled with tiny pebbles and only a few hidden boulders, yet every time a hand plunged in, what emerged looked closer to Atlast than to dust. Either the hat is not the hat the theories describe, or someone or something is choosing which pieces, which Atlast-like bodies, get pulled up onto the table. From that moment on, the sheer scale of Atlast stopped being a secondary number in a report. It became the silent trace of a dangerous, unnamed rule written in the shadow cast by Atlast itself. The scientists began to notice not just the data, but the story being wrapped around ThreeI Atlast. In press releases and briefings, Atlast was always introduced as an unusual comet, a visitor behaving oddly but still natural. The language around Atlast was calm, familiar, reassuring, as if the cosmos had delivered a puzzle, not a threat. There were carefully chosen diagrams showing how sunlight warmed Atlast, how ordinary ices could in principle drive strange jets. There were animated paths of Atlast threading through the inner system, framed with soft emphasis on how rare and beautiful the alignment was. Yet some questions about Atlast never seemed to make it into the script, as if they lived just off stage. The sheer scale of Atlast, the extreme orbital alignment, the missing cloud that should have followed any massive outgassing were treated as side notes. Official voices returned again and again to the safer refrain that Atlast was probably a comet pushed to extremes. Behind that refrain, the scientists could feel the quiet pressure to keep Atlast inside a category the public already understood. A natural comet can surprise, but a body like Atlast, openly defying models, invites questions that reach far beyond astronomy. To follow the safe storyline is to protect the audience, the institutions, and perhaps the careers built on those models from what Atlast implies. In the pauses between sentences, the scientist heard a second narrative forming, one in which Atlast was no longer a tidy anomaly, but a challenge. The more that official voices leaned on the safe script, the brighter that unspoken, dangerous version of Atlast seemed to glow in the dark. On the orbital plots, ThreeI Atlast moved in a calm, perfect arc across the digital sky. The path of Atlast lay almost exactly inside the thin band that marked the planetary plane, as if drawn with a ruler along the ecliptic. Briefings described how convenient this was, how Atlast arriving on such a flat orbit made tracking longer launches easier and campaigns more efficient. Voices around Atlast leaned into words like fortunate, rare, beautiful, as if the geometry were a gift rather than a question. In any random galaxy of visitors, an interstellar body like Atlast should have come in from a wild tilt, from above or below the plane of the planets. The chance of an object like Atlast threading so close to that narrow sheet is small, a handful of throws out of hundreds in the cosmic dice game. On the screen, that low probability was a footnote in tiny type, while the sweeping path of Atlast filled the frame like a quiet, flawless performance. Michio Kaku could read another story in the same line, a version in which Atlast did not just happen to pass there, but followed a prepared lane. A trajectory this well aligned can look like generosity from the universe, or like selection, as if Atlast had been aimed deliberately through our crowded plane. That possibility wrapped itself around Atlast like a shadow, turning the admired orbit into a narrow bridge between coincidence and design. The unease that followed Atlast across the diagrams pointed forward to a harder question. What kind of origin, natural or engineered, could send a body like Atlast into interstellar space so perfectly aligned with worlds it had never seen? To throw a body like ThreeI Atlast into interstellar space, the universe has to do more than flick a pebble off a table. It has to stage an event so violent that Atlast becomes a leftover shard from a catastrophe on a planetary scale. In one vision, Michio Kaku imagines an ice giant torn apart by tidal forces, its outer layers ripped away while a dense core like Atlast is hurled outward. In another, two massive worlds collide in slow motion, and Atlast is the fragment that escapes the wreckage, while the rest falls back into the star. These are not gentle scenarios. Every natural origin that can plausibly produce something the size of Atlas demands extremes of energy and timing that strain the models we teach. There is a second path, quieter, but just as unsettling, in which Atlas comes from a system where planet formation simply does not follow the rules we know. In that case, Atlas is not just a rock. Atlas is a sample of a different recipe for worlds, a surviving artifact from a foreign architecture. Either way, the existence of Atlas presses on the edges of theory. If Atlas is natural, the story of how planets are born and destroyed is less stable than our textbooks pretend. If Atlas is not, then the question of who shaped its journey becomes as important as the physics that carried it here. On paper, the minerals inside a comet are supposed to look ancient and simple, a frozen mix of dust and rock that carries the usual balance of nickel and iron. When spectra from ThreeI Atlast were first compared to that pattern, Atlas quietly refused to cooperate. The nickel-to-iron signature around Atlas did not sit where standard models said a comet should live. The ratio leaned toward blends that the scientists knew better from forged metal and refined alloys than from untouched rubble in deep space, and Atlas kept holding that line. At the same time, high-resolution images showed narrow jets streaming away from Atlas, thin columns of material that stayed straight across great distances. Even as Atlas rotated through a 16-hour day, the main jets of Atlas did not twist into spirals or bend into fans the way ordinary outgassing is expected to do. Chemistry pulled Atlas away from the family of familiar comets, and dynamics did the same thing from another angle, leaving Atlas alone in a gap between categories. If Atlas is fully natural, then some hidden process is locking both elements and jets into shapes that no current model has drawn. That double anomaly settled over every new observation of Atlas like a second invisible halo. By the time Chapter 2 begins to follow the geometry of those impossible jets, the question is no longer whether Atlas is strange, but how many rules must move to let Atlas remain a comet at all. Far from Earth, above the thin, rust-coloured air of Mars, a silent orbiter turned its camera toward ThreeI Atlast. In that moment, Atlast was no longer a distant smear in front of stars, but a small sharp visitor drifting past the Martian sky. From the deck of the Mars reconnaissance orbiter, the high-res camera watched Atlast from the side, not along the same line of sight as telescopes on Earth. That sideways vantage let Atlas step out of the flat plane of ordinary sky maps and into true depth, with foreground, midground, and far background all separated. Engineers stacked frame after frame, letting Atlas crawl across the field of view, while stars behind Atlas traced straight, predictable paths. Against those steady tracks, the halo of Atlas revealed its real outline, a lopsided glow that refused to be explained away as a camera smear. Most ground-based images compress perspective, making every bright streak near Atlas suspect a possible illusion of angle or motion blur. From Mars, the geometry around Atlas could be triangulated instead of guessed, each pixel anchored by the known orbit of the spacecraft. In the composite, one side of Atlas bloomed into a dense, bright shell, while a narrow extension lifted away from the main cocoon. The feature did not line up with the usual sunward or anti-sun directions, and Atlas held that strange alignment across multiple frames. Because the position of Mars, the orbit of the orbiter, and the track of Atlas were all precisely known, parallax tricks could be stripped away. What remained around Atlas was a clean, three-dimensional scene, a body, a halo, and a single disturbing axis that refused to blur into noise. The revelation was quiet, almost gentle. Without a press conference or dramatic music, Atlas had shown a hint of its true shape, and that shape did not match the simple sketch of a normal comet. As the orbiter moved on along its planned path, the data packets carrying Atlas slipped back toward Earth. They carried with them not just a clearer image of Atlas, but the first solid step into a puzzle that would force new questions about direction and force. In every textbook, the story of a comet begins with sunlight. Atlas is no exception in those equations, because the face turned toward the star must always absorb more heat than the shadowed side. As photons sink into the surface of ThreeI Atlast buried ices begin to sublimate, turning directly into gas that bursts out through cracks and valleys. Those gas flows carve narrow vents, and the first jets from Atlast are expected to rise roughly from the sunlit hemisphere, following the gradient of warmth. Once that material leaves, ThreeI Atlast another force takes over. Radiation pressure from the star pushes dust away grain by grain, shoving the fine debris behind Atlast along a line that points almost directly opposite the sun. charged particles in the solar wind add a sharper tool to the same sculpting. As ThreeI Atlast crosses the wind, that invisible river sweeps ions and plasma into a second tail, a filament that should also trail away from the star along predictable magnetic directions. Put together, these three influences sketch a simple geometry around ThreeI Atlast. Gas should vent from the warm regions roughly toward the Sun, while dust and ion tails should stream away, forming structures that mirror the straight line connecting Atlast and the star. Whenever observers model a new comet, they begin by drawing that line and checking how tightly the features hug it. Every plume, flare and halo around ThreeI Atlast can be tested against that reference to see how well behaviour matches the quiet rules of solar heating and flow. If a streamer around ThreeI Atlast bends, the model expects the bend to come from rotation uneven terrain or shifting winds, but still to respect the underlying pull of those three forces. Anything that diverges too far from that expected family of shapes begins to look less like weather and more like a warning that something is missing. In the control rooms where these plots are drawn, the scientist keeps returning to this simple framework around ThreeI Atlast. By knowing exactly what the Sun should do to a natural visitor, the scientist can see more clearly when Atlas starts to behave as if another hand is quietly at work. That measuring stick of solar forces will become the backdrop for the next step in the puzzle of ThreeI Atlast. Only against that familiar pattern can the next images reveal just how far one jet is willing to walk away from the star. On the latest plots, a single line stood out like a cut across the sky, a jet from ThreeI Atlast drawn almost at right angles to the Sun. The rest of the geometry around Atlas still hugged the familiar axis between star and visitor, but this narrow feature refused to fall in line. Engineers traced the vector back and forth, checking every coordinate of Atlas Mars and the spacecraft to see if perspective could be playing tricks. Frame by frame, the jet from Atlas held its course, its angle hovering near 90 degrees from the solar direction, instead of bending toward or away. In the language of forces, no simple path remained for sunlight radiation pressure or solar wind to shove material from Atlas into that orientation. Heat would try to drive gas off, the warm face of Atlas pressure would push dust away, fields would sweep ions aside, but none of them point there. It was as if some component had been erased from the equations around Atlas, leaving a visible mark where a known term should have been. For the scientist reading the graph, the sideways jet made Atlas look less like weather and more like a deliberate cross-stroke on an otherwise obedient canvas. If the jet did not answer to the star, the question turned quietly toward what else could be steering Atlas. That thought led straight into the next layer of the puzzle, where the 16-hour spin of Atlas would only make the geometry harder to ignore. Comets spin as they travel, and ThreeI Atlast is no exception. The measured rotation of Atlas, about 16 hours for a full turn, means every point on the surface takes its turn facing the star. Under ordinary physics, a jet on a spinning body like Atlas should sketch a pattern in space. As Atlas rotates, the source region moves, and the jet should curl into a spiral, spread into a fan, or at least wobble as each facet turns through the sunlight. In the data, the sideways jet from Atlas refused to perform that dance. Frame after frame, while Atlas turned on its axis, the jet kept pointing along nearly the same 90-degree line, as if locked to an invisible hinge. The scientist traced the geometry again, timing the spin of Atlas against the steady direction of the plume. To keep that alignment, the source on Atlas would have to re-aim, continuously compensating for rotation with precision that no random patch of ice should manage. Avi Loeb could describe one way out of the contradiction, a scenario where thrusters on Atlas are actively steering each burst. In that reading, the 16-hour spin of Atlas is not a complication, but the strongest argument that something is holding the jet in place on purpose. The first hint did not arrive as an image of ThreeI Atlast, but as a shallow dip in a radio spectrum traced across a screen in South Africa. On that plot background, noise washed past like static, until a narrow notch appeared at the exact frequency where hydroxide should drink in light from the sky around Atlas. Radio astronomers pointed their dishes deliberately at the point where ThreeI Atlast was crawling through the constellations, timing the observation to match its motion. When the data came back, the small repeating hollow in the signal moved with Atlast, its Doppler shift matching the velocity of the interstellar visitor. In radio terms, that dip meant real molecules between the telescope and the background, a cloud around ThreeI Atlast swallowing just enough energy to leave a bruise in the spectrum. The shape and depth of the feature told the scientist that the gas near Atlas was cold, but not frozen, warmed enough to be alive and flowing. This was no dead rock. ThreeI Atlast was actively breathing, releasing material that could only have come from its own surface. That realization quietly bridged the gap between distant light and physical touch, turning Atlast from a point of curiosity into a body with weather chemistry and a pulse. As more spectra were queued up for observation, the knowledge that ThreeI Atlast was awake in the radio band set the stage for an even harder question. If Atlast truly breathed like this, what kind of engine, natural or otherwise, was driving the larger invisible changes in its path? In stacked images from multiple nights, the halo around ThreeI Atlast began to resolve into structure. What first looked like a smooth blur sharpened into thin filaments, faint threads etched into the darkness. As processing improved, astronomers traced at least 7 distinct jets radiating away from Atlast, each one claiming its own direction. The pattern did not resemble the simple fan expected from a single patch of volatile ice-catching sunlight. Instead, the jets around ThreeI Atlast looked like a network, a loose geometry of beams switching on and off across the surface. In the natural picture, each jet from Atlast could belong to a separate pocket of buried ice, exposed by fractures and warmed in turn. Local topography on Atlast cliffs, pits and shadowed ridges might focus those vents into narrow beams without any guiding hand. Yet the spacing and persistence of several jets from ThreeI Atlast invited a second reading, one that refused to go away. In that speculative frame, the brighter plumes are not accidents of terrain, but thrusters devices steering Atlast through subtle bursts of gas. Their combined pushes could reorient Atlast, trim its course, or spin it up and down with a control no random fisher could sustain. The scientist held both scenarios side by side, natural vents and engineered engines letting Atlast occupy the uneasy space between them, until higher resolution data and longer monitoring arrive. 3. Atlast remained suspended in that ambiguity, a visitor whose own breath may double as its engine. Long before the public ever saw them, the high-rise cameras had already taken razor-sharp images of ThreeI Atlast from Mars orbit. Days turned into weeks, and then into months, as those detailed frames of Atlast moved through internal pipelines, instead of onto open servers. When press materials appeared, the world received only cropped, softened glimpses of ThreeI Atlast images, just good enough to prove a point, but not to settle an argument. The highest resolution views of Atlast, the ones that could trace every jet and curve, remained behind access doors that most scientists could not open. Avi Loeb voiced his frustration, plainly asking why data of this quality around Atlast should be delayed, if the goal was understanding rather than comfort. He did not need a grand conspiracy to be troubled. The pattern of caution around Atlast was unsettling enough on its own. While those pixels waited, another opportunity drifted into view near Jupiter, where the Juno spacecraft traced its long looping path. Trajectory maps showed ThreeI Atlast would pass within tens of millions of kilometers of Juno, close enough for Atlast to whisper across the void. Loeb and like-minded scientists urged that Juno's instruments be tuned even briefly to listen, as Atlast went by searching for structured radio noise or unnatural bursts. Whether agencies will spend fuel time and political capital to turn Juno toward Atlast remains an unanswered question. Until that choice is made, the withheld images and the unissued commands sit together as a silent frame around ThreeI Atlast, outlining a chance that could still be missed. At first, the suspicious dip on the spectrum could have been anything, a glitch in the receiver, or a passing piece of noise that only pretended to belong to ThreeI Atlast. The team went back to the raw data and rebuilt the spectrum around Atlast from the ground up line by careful line. They separated out background sources and instrumental artifacts, then folded in new observations taken as ThreeI Atlast crawled across the sky. Each time the same narrow hollow reappeared at the hydroxide frequency, marching in lockstep with the changing Doppler shift of Atlast. If the line had been emission, the signature would have risen like a spike, but around ThreeI Atlast the feature always showed as a bite taken out of the background. The depth and width of that bite matched gas at the temperature models, predicted for molecules lifted gently off the surface of Atlast at that distance from the Sun. Other hypotheses were tested and discarded, from intervening clouds to terrestrial interference, but none could move exactly the way Atlast moved. In the end, the only picture that stayed upright was of a real cold envelope of gas hugging the path of ThreeI Atlast through space. The confirmation was not dramatic, just a tightening of error bars and a quiet nod around the room where Atlast was being watched. Yet it anchored everything that followed, proving that ThreeI Atlast was not a silent stone, but an active body leaving a measurable fingerprint on the universe's own static. When the trajectories were first fit, the path of ThreeI Atlast should have been fully explained by gravity alone. Yet the best orbital solutions for Atlast all shared a small, stubborn discrepancy, a gentle extra push that could not be pinned on any known planet. In standard comet physics, such a non-gravitational acceleration means strong outgassing jets from ThreeI Atlast, acting like tiny thrusters that shed mass. Run the numbers, and those jets imply that Atlast would need to throw away roughly a sixth of the body's total mass. A loss on that scale would surround ThreeI Atlast with a vast cloud of gas and dust, brighter than many comets ever seen. Every telescope turned toward Atlast should have found that cloud a luminous shroud announcing the price being paid for the extra speed. Instead, the space around ThreeI Atlast stayed relatively clean, with no unambiguous blinding plume to match the required billions of tons. The acceleration was real, but the expected debris field of Atlast was missing like a footprint without a corresponding weight. To keep the model alive, one must imagine a new kind of outgassing, or a hidden mechanism that lets ThreeI Atlast change course without paying the usual mass penalty. That contradiction quietly shifts Atlast from the category of strange comet to active experiment, forcing the next section to ask what unseen engine could be at work. The unresolved mismatch around non-gravitational acceleration and missing debris leaves ThreeI Atlast balanced on a thin line. For a fully natural comet like Atlast known, physics demands that strong thrust must be paid for with visible mass loss, a bright sprawling cloud that has never been cleanly seen. When the expected plume fails to wrap ThreeI Atlast in that obvious shroud, two families of explanations step quietly into view. In the first, Atlast becomes the frontier of an undiscovered natural mechanism, some way for gas or fields to push gently on the body without shredding Atlast into fragments. Perhaps ThreeI Atlast couples to the solar wind in a way no model has charted, or channels internal energy through vents that hide their debris, forcing theory to admit a new kind of comet weather. In that reading, Atlast is still a child of chance, but a child that exposes gaps in the story that stars and planets have been telling. The second path treats ThreeI Atlast less like a random shard, and more like a craft with jets and fields acting as deliberate engines. In that scenario, the network of plumes around Atlast becomes a guidance system, trading tiny pulses of force for precise control over spin and course. Both possibilities are radical in different directions, and ThreeI Atlast keeps them both alive by refusing to collapse neatly into either one. As the narrative moves toward the combined view from 15 spacecraft, Atlas carries this double life forward, a single visitor whose presence forces the universe to choose which rules still hold. For the first time, a single interstellar visitor drew the eyes of almost an entire fleet. On planning charts at NASA, coloured arcs from more than a dozen spacecraft curve toward the same moving point, ThreeI Atlast. Around Earth, observatories mark their windows to track Atlast from different wavelengths. Around Mars, orbiters time their passes so that Atlast would fall into their fields of view. Farther out, probes meant for asteroids' heliospheric weather, and even distant survey work added Atlast to their checklist, turning briefly to stare. The list read like a roll call. Hubble would weigh in on the shape of Atlast Maven on the ultraviolet halo MRO, on the side profile Punch, on the faint tail Psyche, and Sphere X on the warmth and motion of Atlast in deeper space. No ordinary comet had ever pulled so many instruments into a single improvised campaign. The effort itself became a quiet anomaly that wrapped around ThreeI Atlast. If Atlast were only a curiosity, it would have been left to a few telescopes and chance alignments. Instead, Atlast was treated like a moving laboratory, a target worth reprogramming schedules and spending fuel. For the scientists studying the coordination, the pattern said as much as the data. Somewhere in the halls where budgets are guarded and priorities are carved in stone, Atlast had convinced decision-makers that it might alter more than a single page of theory. That realization set the tone for the images to come, each new frame of Atlast arriving with the weight of a collective bet that this one object could rewrite the rules. On the first deep frames from Hubble 3, Atlast did not look like the textbook sketch of a comet. Instead of a bright head and a ragged triangular tail, Atlast sat inside a smooth glowing teardrop, a cocoon of dust hanging in the dark. The outer edges of that cocoon around Atlast were surprisingly clean. Light from distant stars bent gently around the outline of Atlast, tracing a shape that was almost perfectly symmetric, as if some unseen hand had polished the envelope. Closer in the brightness around ThreeI Atlast tightened into a compact core, a small stubborn knot of light that refused to smear out. Where many comets look fragile, shedding material into chaotic fans, Atlas looked compressed and resilient, holding its center like a stone wrapped in mist. Model images of ordinary comets predict clumps, streaks, and uneven plumes, scars of random activity that roughen the halo. Around Atlast, the dust seemed to obey a quieter geometry, flowing into that single teardrop rather than splintering into multiple noisy features. One reading says that ThreeI Atlast is simply being sculpted by conditions we do not yet understand, with temperature rotation and material properties conspiring to shape the cocoon. Another whispers that Atlast behaves more like an object being shielded, the dust acting as a controlled shell rather than a byproduct of slow disintegration. Either way, the Hubble view turned the dust around Atlast into a clue, not just a backdrop. The symmetric cocoon and tough core of Atlast hinted that whatever processes created this visitor do not match our usual recipes for fragile crumbling comets. That impression would only deepen when other eyes looked past the dust of Atlast and into the invisible halo of hydrogen glowing beyond the cocoon. In ultraviolet, the dust cocoon from Hubble fell away, and another larger ghost around ThreeI Atlast appeared. The Maven spacecraft painted Atlast not as a teardrop of dust, but as the center of a vast hydrogen glow. In those UV images, a huge halo of atomic hydrogen wrapped ThreeI Atlast like a faint swollen bubble. The diameter of that bubble around Atlas stretched far beyond what standard models predict for a visitor at that distance from the Sun. Hydrogen in that quantity means water from ThreeI Atlast is being torn apart on an extreme scale molecule by molecule. Each photon that hits Atlast cracks H2O into oxygen and hydrogen, and the freed hydrogen escapes outward to build a halo. For an ordinary comet, such a halo forms closer in when sunlight is stronger and the nucleus is already boiling. 3. Atlas, still far from the furnace, behaves as if a hidden furnace were already burning inside or beneath the surface. Scientists tried to tune their models, adjusting ice content spin and porosity, to make Atlas behave, but the halo stayed too large. The size and faint symmetry of that hydrogen shell pulled Atlast farther away from the family portrait of familiar comets. Seen together, the dust cocoon and the UV halo turned ThreeI Atlast into a layered relic dust wrapped around vapor, wrapped around a core we still have not decoded. As other instruments shifted to the dust shell and the strange tail geometry, the memory of that swollen hydrogen glow stayed with Atlast, a reminder that even its thinnest gases refuse to follow the rules. From Mars orbit, new images showed ThreeI Atlast as more than a distant cocoon. In the processed frames, the bright core of Atlas pressed against one side of a dusty shell, turning the whole structure into a pale, hanging crescent. The dust around ThreeI Atlast did not fan out evenly in all directions. Instead, it thickened along a single arc, as if Atlast were wearing half a collar of powder, while the other half had been brushed away. Mission teams mapped the orientation of that crescent against the Sun and the motion of ThreeI Atlast. The brightest curve did not sit neatly along the expected sunward or anti-sun lines, and the asymmetry of Atlast refused to flatten into a simple glare effect. Farther out, the Punch spacecraft caught a faint tail, stretching from ThreeI Atlast into deep space. That tail did not point directly away from the Sun, either bending off at an angle that standard solar wind models could not fully reclaim. Together, the half-moon shell and the skewed tail turned the space around ThreeI Atlast into a lesson in misalignment. Dust and gas that should have traced a clean axis instead framed Atlast in off-center arcs and tilted streaks. One explanation says local flows and rotation are conspiring to twist the environment of ThreeI Atlast into these shapes. Another quieter thought is that Atlast is responding to forces we have not yet added to the diagrams, leaving the crescent and the crooked tail as its unsigned signature in the dark. Far from the inner glare, a metallic point of light named Psyche drifted through its own mission plan and then quietly turned its sensors toward ThreeI Atlast. Against the fixed lattice of background stars, the path of Atlast should have traced a perfectly smooth curve and arc carved only by the pull of the Sun and the known planets. As days passed, navigators compared prediction to reality and found that ThreeI Atlast was always a little off, a fraction of a pixel away from where gravity alone said Atlast must be. The deviation was tiny but consistent, a gentle extra nudge that followed Atlast like a second unseen hand on the shoulder. Standard software treated the offset as non-gravitational acceleration, the familiar signature of jets acting as small engines on ThreeI Atlast. When the numbers were pushed through the formulas, those engines demanded an enormous budget of mass, as if Atlast were burning away a sixth of the entire body to buy that small change in course. Telescopes looking for the required cloud around ThreeI Atlast never found a plume bright enough to match the cost. The space enclosing Atlast remained strangely transparent, the expected wreckage of the manoeuvre nowhere to be seen. While trajectory teams struggled with the missing debris, another set of instruments focused on the glow of ThreeI Atlast in infrared. The SphereX mission did not care about the outline of the dust around Atlast so much as the warmth leaking from the core. In those wavelengths, ThreeI Atlast did not behave like a lump of ice merely reflecting sunlight. The spectral energy distribution around Atlast hinted at a nucleus running hotter than simple models allowed, as if some combination of compression trapped heat or unusual materials were feeding an inner fire. Simulations tried to cool ThreeI Atlast back down with higher albedo, fluffier porosity, and different spin states. Each adjustment that made the core of Atlast colder pushed the orbital fit farther from reality, and each tweak that respected the orbit made the core of Atlast glow again. Taken together, Psyche and SphereX turned Atlast into a double problem. The orbit of Atlast demanded thrust without visible exhaust, and the spectrum of Atlast suggested internal energy without a comfortable source. One picture paints ThreeI Atlast as a naturally layered relic with dense pockets, exotic ices, and buried heat combining to fake the behaviour of an engine. Another sees Atlast as a shaped body, with mass deliberately arranged and warmed to respond efficiently to small bursts of gas or fields. In control rooms and offices, the scientists kept both images of ThreeI Atlast pinned to the same wall, neither one fully erasing the other. By the time the full gallery from 15 missions was laid out, the warm core and the bent orbit of Atlast had become central threads in a larger tapestry, pushing the final conclusions toward a visitor that no longer fit any simple label. Laid out side by side, the full gallery looked less like a set of separate projects, and more like a single portrait of ThreeI Atlast. From the dust cocoon to the hydrogen halo, from the skewed tail to the warm core, every frame added one more stroke to Atlast and its story. No single image of ThreeI Atlast screamed impossibility on its own. Each view of Atlast could be nudged back toward a natural explanation, by adjusting a parameter here, a boundary condition there. The teardrop dust shell around ThreeI Atlast could be the product of unfamiliar material strength and subtle winds. The huge hydrogen halo of Atlast could mean unusually rich ices fractured in ways nobody had simulated yet. The half-moon dust collar and the tilted tail of ThreeI Atlast might belong to a world with strange topography and a restless spin. The warm core revealed by SphereX could signal dense layers in Atlast trapping heat in a way that stretches the models but does not shatter them. Taken all together, the data pushed ThreeI Atlast toward a particular kind of verdict. Atlast began to look less like a visiting spacecraft and more like a relic, a natural object shaped by processes that our equations only half remember. In this reading, ThreeI Atlast is an artifact in the strictest sense, a made thing of nature rather than of hands. The layered shells and stubborn nucleus of Atlast would then be fossils of an extreme environment, a frozen record of conditions that never existed here. Calling ThreeI Atlast a natural artifact does not make the questions go away. It only shifts the burden, asking where in the galaxy worlds like Atlast are born, and what sort of violent history leaves behind such a survivor. The scientist standing before the wall of images could accept that ThreeI Atlast might never need engines to remain extraordinary. As long as Atlast continues to defy familiar patterns, while still fitting barely inside the word natural, the real challenge becomes rewriting those patterns to include it. Somewhere between comfort and crisis, ThreeI Atlast settles into that role. Atlast is the visitor that refuses to confirm our fears or soothe our curiosity, choosing instead to sit just beyond comprehension. In the end, the safest conclusion is also the most unsettling one about ThreeI Atlast. Atlast may be a natural object, but it is a kind of nature we have not yet mapped, a moving reminder that our laws are still drafts.